All right, thanks everyone for coming in. I'm Sam. Some of you may have seen me or worked with me in the past, and yeah, good to be back. I've think come back to this one after about almost 5 years. Yeah, I used to present quite a bit, and yeah, took a bit of a break, and thought I'll kind of restart the passion for sharing what I know, and keen to hear from you guys as well as to what you experience, and it's always good to share. So, all right. Yeah, so I'm the head of engineering at Discovery Parks. You may have seen Discovery Parks or stayed in one of the parks. Been in the software space for the last 20 plus years. Started as a developer, and now playing a leadership role, I guess. So seen things, done things, heard things. So so keen to share, I guess, like a combination of all my experience, and leave some of that stuff with you guys. Been playing in the government and the enterprise space, and I have I guess one of my passions within IT itself is architecture, best practices, how can we improve things, how can we do things better, and yeah, when I'm not on my PC, I'll be doing some photography or home automation, and if there's any fans, happy to share any tips on that stuff as well. With that, so developer experience, some of you may have heard the term, or been going through, I guess, the challenges, or trying to fix them, trying to improve them. And so I just want to, I guess, cover off some of the basics as well, for those who are new to the concept. What's developer experience, why it matters, like why it's so important. Some of the research findings, I'm not going to bore you with tons of research papers. I mean, there's plenty of links that I will share afterwards, and some of the strategies that I use to improve developer experience as well. Whether there's a non-technical, technical, there's various things that you could try, and yeah, just want to share some of that stuff with you. And I guess out of those strategies, I will then do a couple of demos on some of the tools as well. Everyone loves tools, and then finally talk about how can we measure developer experience, and what does that mean. So yeah, let's get started. So yeah, so you might see a couple of acronyms, I guess. So DX or DevEx, DevOps being the most popular one, and so everyone's got DevOps, but I guess the developer experience is more about creating an environment, for engineers in general, is how I see it, not just developers, because testers matter too. Do we have any testers by any chance? Yeah. So yeah, testers matters too. It's not just about developers, even though the term is developer experience. So I almost take it as a bit of an engineering experience or engineer experience, and it's about having having an environment where engineers can do their best work, have good outputs, and not just for the individuals as well, or for the team, but for the organization, eventually. And it's a kind of upcoming term. I mean, not so much. I mean, it's been kind of coming up in the last maybe 1 or 2 years, because DevOps has been quite big as a keyword, or as a way of doing things. But then then you also have developer experience as well, as a way of, I guess, going to another level. I guess going back to the history, I guess, when we were doing basic software programming, early days of, I don't know, maybe .NET, almost 15 plus years ago when .NET came out, or if you were doing programming in other languages, early computing was very, I guess, waterfall. You got a team, you get stuff done, I guess, whenever you want to kind of get stuff done. And then I guess came the principles of agile, doing more rapidly, principles of MVP and all of that stuff. And then agile was a big thing, and it still kind of is a big thing. And then I guess agile kind of I don't want to I guess so say the wrong thing about agile, but I guess with agile you also get other complexities. Therefore I guess the principles of DevOps came about to satisfy the needs of faster outputs, quicker software delivery, etc. And then DevOps has now given us an environment, and here we are talking about how do we now kind of deal with the cons of DevOps. So I guess that's kind of how the terms have evolved kind of. And I guess eventually the goal is to make the developers happy or engineers happy, because happy devs are productive devs, and we all know how we get bothered when either we get distracted or we can't achieve something and stuff like that. And so keen to hear, I guess, your experience as well. I mean, when we go through some of the key points. So so why do we need to consider this? I guess there's a couple of key main issues or challenges that we all face. It's quite a quite a common thing, innovation. Every time you read a blog or read something in the news, tech news, there's something new innovative coming out. I don't know, probably every minute. I mean, there's so many things going on, and not every developer can keep up with everything. So it is kind of becoming challenging and overwhelming to a certain degree. Again, maybe not everyone, but it is a common trend that there's so many things to learn, so many things to pick up, understand, get your hands on, and we also do have diverse tech stacks. Azure, GCP, AWS, and languages heaps, too many that we can work on. And I guess through COVID, I guess this is has become another challenge as well. I mean, opportunity as well as a challenge. Having hybrid teams, remote only teams, local, I guess, on-site teams, on-site plus, remote, offshore, onshore, we've got so many different combinations, which is all good, but obviously, it's it can also cause some challenges as well. And microservices, who doesn't love a microservice, or 10 or 20? But what that means is, just making things a lot more complex. You've got too many things to deal with. And sometimes you might think wish we had a monolith, just one app, one deployment, you're done, and not 20 deployments or 20 things. And cyber threats, again, it's everywhere. Anyone could get affected by cyber, and I guess the responsibility also lies, not just within, let's say a cyber team or a cyber person, but it goes all the way back to your software development as well. If you write insecure code and stuff like that, then the issues start there. So again, it's kind of put a bit of a burden on developers as well, not just your IT team. Quality versus speed. Who loves quality? Quality over speed. Oh, speed over quality. Yeah. So I guess the others are 50-50. I mean, this is a very common debate as well. We need stuff tomorrow or yesterday, versus actually we want to do something better. We want to improve the code, refactor the code. It's going to take us I don't know, say 2 weeks, but no, you don't have 2 weeks. You've got to get something out the next week. So this is kind of an ongoing debate worldwide, and I guess you had to understand why quality matters and why speed matters as well. And it's a balancing act. You have to balance out, when speed, should be kind of given some preference versus quality. The cognitive load. As developers or engineers, we had to know a lot of stuff. It's good to have wikis or documents or screen recordings or whatever, a notepad. Information is still key for developers. As much as we can Google stuff, when it comes to learning about your own stuff, whether it's about something that your another team within your organization does, or maybe another team member does in your same team, or a different part of the same business or organization, developers in general go through a big cognitive load, having to know what APIs, what endpoints, URLs, secrets, credentials, parameters, etc. So so we will address some of that stuff as well. And then inter-team dependencies. When you're especially working on large teams, then it becomes a challenge to make sure that you learn from each other, or make sure that there's no conflicts. Learn from one another. Maybe you got a team, where you collaborate with for a, API, like you might use someone else's API or somebody else might use yours. So teams, like when you have a larger team or multiple smaller teams, like, you have a lot of like dependencies in between them, which can also kind of, lead to, frustrations and challenges. So the whole point of, I guess, like, having, the principles of DX or these strategies is to, increase productivity. So increase productivity, I mean, like, it's a big topic. Like, we want everyone to work, faster, but we actually want everyone to work, faster plus smarter and efficient as well. Because there's no point in, like, rushing a build or rushing a bug fix and then, like, getting into issues afterwards. So, might as well, like, do it right the first time. So it is a challenge. And we do want to achieve, like, better quality software. So hopefully the testers will agree with me, like, the less bugs they see or they find, like, they'll probably be happy. And what it also means is more reliable products and softwares, that we deploy. And developer experience is also about, like, fostering innovation as well. Like, if you're just, getting stuck in the same stuff, like, you probably don't have any time to innovate because, it's just another additional thing that you need to do. Innovative teams, like, research has shown that where you got, like, a higher amount of developer experience, like, people innovate more, which means, like, you will actually get stuff done, like, not just not more efficiently, but you can also contribute back to your organization as well. Faster time to market, I think it's a given. Like, everyone needs everything, like, yesterday. Continuous improvements, and then like, talent, attraction and retention. Simon's not here, so we can talk about it. It's it is a real problem. As much as there are jobs and stuff like that, like, it's actually really hard to attract good talent, like, organizations have a lot of trouble finding good people. And obviously we've got people like recruiters or referrals and stuff like that, but it's a common challenge because with COVID and stuff like that, developers and engineers got, like, more opportunities. So it's harder to find, because, like, maybe you got too many, and people got too many choices as well. Not just I just want to work within Adelaide. Like, I could work for any organization in the world. And then once you have good people in your organization, it's hard to retain them. And you don't want, like, anyone burning out, like, anyone, like, getting frustrated, leaving the organization. You want everyone to be happy and then staying back. So DevOps versus developer experience. So some people think, like, having DevOps is enough, I guess. Having your pipelines, CI/CD, all of that stuff, having that is enough. But it's not just the only thing. Yes, DevOps gives us, like, some tools, pipelines, infrastructure as code, getting stuff deployed. But then developer experience is about, like, your, like, the daily life, the environment, the processes that you use or procedures that you use, your everyday workflows, and obviously tools as well. And I guess, like, to reach a higher level of developer experience, you kind of need both of them, not just, like, one or the other. And I hope, like, DevOps is quite standard these days in any organization or any team. You got your pipelines configured, so most of that stuff is done. But, like, that is actually not enough, according to research. So some of the research findings. So there's been, like, a lot of research done in the last, like, almost 1 to 2 years. GitHub, like, Atlassian, Microsoft, they all spend a lot of time, like, researching and like, looking at, I guess, like, ways to improve and the root causes. So there's, like, a fantastic research paper on developer experience and other, like, challenges and way to solve them. I couldn't actually get the resources slide up, but when I actually share my slide deck later on with David, I'll actually put all the links in there. The research papers, like, talk about how they measured, like, what variables, what parameters, what they did to actually uncover these hidden facts about developer experience, which is why this is a big topic. Even though it's not kind of mainstream, it is a real problem. So based on GitHub, like, they've come with a bit of a formula, and they did like a massive survey as well last year, and based on that, what they found, like, as a common formula to solve this challenge is to have developer productivity. It's about like how quickly can you do stuff. I've got a ticket assigned to me. Can I get a fix out, or can I get a change out? And then having any impact on the developers. Like am I getting blocked by any other team, or like do I have permissions? Like can I deploy, or am I whatever it is. Like do I need permissions from someone? Do I need to email someone and having to wait? So it's about like how much of an impact it's got on the devs. And then like overall satisfaction. How happy am I with the tools that I've got? The ways of doing stuff. Within your Scrum process or Agile process, etc. And then that can lead to developer experience. If you see the parentheses, C equals collaboration. So out of all of this stuff, like collaboration is still a key factor. And even though we've got like Teams and Slacks and emails and chats and stuff like that, I guess having a good level of collaboration with your team members and other teams is still a key factor in reaching the goal of improving developer experience. So go into some of our strategies. So there's a strategy around having a sprint zero. Anyone follows that concept of a sprint zero? Yeah, good stuff. Heard about it? Not yet implemented. Yep. So everyone loves their sprints. Sprint 1 gets started, but I guess like what some teams could forget or might forget, or stakeholders may forget, is that like you still need to get like some of your other stuff together. Like you got to get your act together. Have your code bases ready. Like can you build the code? Like can you deploy? Have you got your infrastructure set up? I mean that could be part of sprint 1 as well. But most common like sprint 1 is about like writing code. Okay, I'm like we are running. We are a running team, I guess. So sprint 0 concept is around like having that baseline set up before you actually move into your functional work. And then like just making sure that like all your pipelines and infrastructure, and as much as you can do. Obviously you might need a piece of infrastructure in sprint 3, but anything that that you need to start, like get them done in a sprint 0. It's still in the backlog. It still is based on the team's capacity and stuff like that. So please work with your Scrum masters or Agile coaches and whatnot to see if they can actually squeeze in a sprint 0 before you actually start your actual coding. Optimize documentation. Who loves documentation? Who doesn't love documentation? No? Who drowns in documentation? Yeah, documentation come in all shapes and sizes. Yeah, sometimes it's too many. Sometimes it's too little. And I guess what we need to make sure is that we've got an optimized set of documentation. What really matters. Maybe it's about like learning about APIs or the requirements of whatever you're working on, and maybe like cutting out the noise, like cleaning up the clutter. Like there's probably no point in like having 10-year-old like documentation which is obviously obsolete, unless you're running a legacy platform. So I think like there's a lot of like common just practices around like having some time set aside to actually clean up your documentation as you go. Otherwise, like documentation, what happens to documentation usually?
Sprint never.
Yeah, exactly. Yeah, it's the last thing, right? I mean, and it's the last thing in the backlog plus the first thing to to get chucked out as well. So it is important. Deep work. Based on the research that's been done by GitHub, Atlassian, Microsoft, what they found is like if you're at least 50% able to focus, again like different research talks about different percentages, but let's say the more I guess uninterrupted time that you got in your day, if you're doing 8 hours a day, I don't know 8 to 5, 9 to 5, 9 to 6, whatever, and if you got like a majority of that time, again like if you're part time, same story. It's about having a big proportion of your work time allocated for uninterrupted work where you can like really focus, like go like really deep into what you're working on. But again, it is a bit of a problem. I mean, it is a practical challenge. Yep, someone might like tap you on the shoulder, like ask a question, interrupt, and especially like if you got a new guy on the team, we do love the new guys, but But the thing is, like, someone's got to train them up. Like, they're obviously going to ask questions. So it is just a, it is a given. Like, it's not something that we can get away with. But I guess, we need to start applying some strategies to minimize that. And hopefully, some of the things can lead to more, amount of time spent in deep work rather than, in interrupted work where you do, half an hour, gets pinged on an issue or a chat or a meeting and stuff like that. And it is a practical challenge. Integration and automation, again, it's not a big topic, but I guess integration and automation is kind of big within DevOps, within those tools, within those CI/CD pipelines and stuff like that. Is still an automation. But then, like, there are other tasks that could be automated and integrated as well, which is something that I will cover with a demo a bit later on. Because when it comes to, like, developers themselves, like, I guess integration and automation isn't technically, front of their mind, unless you're actually doing that work, for your actual work. Like, it's not really a concept that's been addressed at a daily life level. Collaboration, I think that's a given as well. Like, having team relationships, and then, like, having a sense of, like, collaboration, because you can't work in isolated, which is again why some teams have issues, because, like, they don't talk that much or don't like to share. But the more you collaborate, like, most of these things will actually just come together naturally. Tech debt, bit of a controversial topic. Some organizations handle it better than the others. Some may ignore, but it's still there. It's everywhere. You can't get away from it. And it's not about how big or small it is. The level of tech debt that you have, but I guess it's the way you go about managing it, and the strategies that you can apply to kind of minimize or maintain and keep it under control. So just like sprint zero, like some of the things that you can do within your agile practices is carving out, like 20-30% of your backlog, as in your capacity. So your backlog can actually have, I don't know, maybe 70% of your capacity spent on, like, functional tickets, whatever, features, bug fixes. But then, like, 20-30%, again, like, you have to play with that percentage yourself with your team and what works for your organization as well. And then, like, have that, as a bit of a, improvement, continuous improvement, tech debt, handling bucket. So you could, like, squeeze in a refactoring task. So rather than having to refactor things on the go, which can lead to more, I guess, like, lengthier, deliverable time, you could actually have a dedicated time set aside just to deal with that. It could be tech debt. It might be, just dealing with something that you want to improve, or maybe a feature that you wanted to add wasn't in the ticket, so I couldn't do it. But then, like, you could deal with that, at a later stage. So they're more like, I guess, like, practical, non-technical stuff. I guess some of the other strategies, which is what I'll be mostly focusing on later on, is strategies around, like, tooling and like technical stuff that you can actually implement, like, yourselves within your teams. So shift left, is a concept where you do your testing and security scanning, security related activities as early as possible within your dev lifecycle. So rather than waiting, to actually, like, deploy something and then say, like, hey, testers, can you go and test this out? Like, testing actually, starts to happen, as soon as, like, development starts as well, within your sprint. So the more that you do, upfront, the more problematic it's going to get, or the less problematic it's going to get afterwards, versus the opposite. Platform engineering. So we'll do a deep dive on that in the next couple of slides. So this is a concept, I guess, taking, or the next evolution of the whole DevOps team concept. Like, some organizations have a dedicated DevOps team or an infra team or what you want to call it. Maybe just one guy or girl within a team who does that stuff. And then there's some tools around, like, making it more pragmatic. Not just it's not just about having a person or a team dedicated to it. Generative AI, it's everywhere. ChatGPT, OpenAI, Claude. Anyone playing with Claude versus ChatGPT for any development stuff? Is that any better? Yeah, cool. And yeah, the fact is, it's here and it's going to stay. No, I don't think it's going to put us out of job because developers still need to do stuff. Even I think like people who use that stuff like know how many times like you got to go back and fix that stuff. So maybe it was better, you were better off like writing the code yourself rather than having it AI generated and then having to fix it. But then it's a matter of like how you can use it for your advantage. So you have obviously your things like I can't remember the name of the AWS one, but GitHub Copilot, Copilot X, and like just your regular Copilot and ChatGPT that you can use. But I'll show like a demonstration of how I've used it for for our benefit or the developers' benefit. Journey mapping, customer journey mapping, user journey mapping is a big topic in the user experience, customer experience space. But we can also map the developer's journeys as well. If you take the life of a developer, a life of an engineer, a tester, every tester, every developer has goes through a bit of a journey. And the more you understand that, like map it out, like just talk about it, then you can actually understand like where your where your gaps are and where you might actually be getting stuck and the pain points. Having a sense of community. So some of the practical stuff that you can do, having tech talks, obviously, awesome that we've got the user groups in Adelaide, such as this one. But you can easily do like a mini user group. Could be a lunchtime session, could be a every Friday, once a fortnight, whatever it might be, within the team, between teams. You could do like little talks and stuff like that, just to actually build that sense of community, share the information with one another, etc. Do it online, do it in person. They're just like little things that anyone can do. And internal dev tools. Everyone builds apps. All developers build an app. But does anyone here build apps for yourself? Yeah, cool. And the unfortunate truth is like we are so focused on like building apps for the others. Whether it's an internal business division or department or a customer, it's always external to your team. So the concept of having an internal dev tooling platform or a strategy is about like having some time set aside. Again, like you need to still get it done, but I'll show you like a platform that I use, and like you can actually quickly build some apps for yourselves, for your team, for the testers, maybe for the BAs to use as well, to actually reduce the manual work that you had to do. Platform engineering. So it's kind of like the next evolution of DevOps. And platform engineering is kind of, it's got like, two principles or two factors. Like, one is about like having a dedicated team, perhaps, or could be a person, and then also having a set of like tools and processes like laid out, to make things streamlined. And the whole point is to empower developers, because like with DevOps, I guess like you could almost have like different teams doing different things. Maybe they're deploying things in a slightly different way. Maybe you're not actually copying your pipeline templates from one another. Like maybe every team has to go through that process of setting up their own pipelines. So what if like the pipelines are there templated? Pick up a pipeline template and then you're good to go, kind of thing. And then standardizing the tools required. Again, we live in a world where we've got like it's a tooling overload. Like there's so many tools, regardless of whether they're open source or commercial. Like there's a lot of like there's at least like 10, 20 tools just for the same stuff. Maybe there's one feature that is different. And again, like to meet all the demands, we do need the tools. But then platform engineering is about standardizing the tools, not like everyone bringing in the tools that they want or they like. But it's about having a standard set of tools that you agree upon, and then the concept of having an internal developer portal as well, which I will go into next. So Gartner predicts that by 2026, 80% of the organizations would actually have a dedicated team and have developed the principles of platform engineering and actually have a self-service portal, which I will show an example of, to accelerate like collaboration and outputs. So there's some more research on that. So internal developer portals. So I'll cover some of the basics, but I will go into a demo very quickly. So an internal developer portal, like, comprised of, like, a couple of key components. You got the control plane, so that's where you can actually document your workloads, components, like, whatever it might be. Could be a microservice, could be a component. Just because, like, just because you got a microservice, like, that's still got, like, individual components inside of it. So you still need to document them. APIs, Swagger specs, a lot. There's a lot. So this layer of the portal would actually be where you document your stuff. And then the next layer would be your integration and delivery plane. So this is where you would actually have your standardized CI/CD pipelines, your tools, and then the platform orchestration. And the concept of platform orchestration is about, like, setting up the infrastructure. So CI/CD pipelines are mostly about just deploying, but then someone needs to look after the infrastructure. DNS, domain names, storage accounts, etc., etc. So you still need to do, like, other stuff, SSLs. So you still need to look after your other components at a more physical operational level, not just your build and deploy pipelines. So platform orchestration is the concept of orchestrating all of that stuff in a central way. And then obviously you got your actual resources, your actual infrastructure. Again, like, regardless of the cloud, this is kind of like a framework that you can apply to any cloud. Monitoring and logging, and then security, credentials, rotating keys, etc. So all of this stuff, the concept is to, like, standardize and centralize all of this stuff. So this is just a bit of an example structure of an IDP, and I've put the link down there as well, which you can read up and get other examples. There's one for GCP, AWS, and other clouds. So from a developer plane perspective, you got your IDE, of course, and then you got your service catalog or a developer portal. So that might be something like Spotify Backstage. Just one example. So I will demonstrate another example in a bit. And then, like, you got your source control and your source code and, like, your orchestration, like, Terraform, Bicep, etc. Then you got your pipelines, GitHub Actions, DevOps pipelines, and then you got your container. If you're into containers, then you got your container registries or your other workloads, and then you got the platform orchestrator that then manages not just the deployments but also the actual infrastructure provisioning and management. And then you got things like Azure Monitor, Key Vault, etc. So definitely have a look at the more practical examples, because that will just give you an idea about what options are there. So GenAI, I'll quickly go through this stuff, and next slide is the demo, which I want to get into. So using generative AI, so you can actually use that quite a bit these days, and you have opportunities and tools available to actually optimize your documentation as well as to put GenAI on top of your documentation. Ask questions about your wiki, your documentation if they're in files, versus they're in SharePoint, versus a different platform, versus they're in something like a Confluence in wiki format. You can easily have generative AI, and in fact, like Atlassian rolled out their AI functionality as well. Code generation, I'm sure everyone's not a stranger for that. And then within my teams, we use that to actually generate a whole API, and where we actually do kind of goes together. We actually use generative AI to actually generate a Swagger spec, out of stories, out of user stories, out of business context, data models, etc. And then say, like, craft a Swagger spec for us. And then we also have come up with a process to then convert that Swagger into an actual running API, that just spit out a .NET Core API project. Probably not going to be perfect in the first go, but that'll still save someone, like, having to read documentation, figure out, like, field names, field types, open API, love it, but who can remember all the syntax, and like, generative AI can do, like, magic in this space. Config generation, again, like, your YAMLs and JSON configs and stuff like that, like, you can easily use GenAI for that. Obviously, you got to do that in a safer way. So definitely consider not the public free options, but more of the private open source stuff that you can run on on your machine versus, in one of your servers or within your, cloud infrastructure in a private setting. And you can also use GenAI quite a bit these days just to query your stuff, like, how many instances did I have, what were the top 5, APIs that, I don't know, had a high CPU, because, like, you don't have to worry about running, writing your, custom queries or, whatever query language that you use, whether you're in Datadog, New Relic, Splunk, like, whether you use a tool or you're simply using, I don't know, SQL Server or, log analytics, like, whatever you do, like, you have to run queries to find that stuff out, but, easily plug in GenAI and then it'll do wonders. Tooling. We still good for time, David? Yeah. Okay, so I'll exit out of that. So some of the key things that I touched on. So I'll just go back a step. So you got the API catalog. So I will share an example of that, as well as I will show some of the tools that we use to maintain and generate our API specs, and also some dev tool platforms and some GenAI. So first of all, creating our APIs. Oops. Readable. Anyone use Stoplight? No? Cool. I mean, there's many products. This is just something that I've got personal experience using. There's an open source one from Red Hat, and there's other stuff. And yeah, you might have Postman. You might have SOAP UI. That kind of stuff as well. But this kind of like goes beyond, which is why I really like it. So yeah, the first time you want to write an API, like the first thing you're going to do is like if you're working on Swagger, I mean you could technically do two things, or you guys might be able to tell me like in other ways as well. Like for me, my basic way would be like spin up a .NET Core API, project, like spin up a bunch of C# classes, get my model right, make sure I've got all my JSON attributes and whatnot, plug in Swagger in startup, spin it up, here you go, I've got Swagger. But then like it may not actually be that much enriched, because all you might initially care about is just getting your classes and controllers and stuff like that, not like the descriptions, the comments. They actually matter quite a bit. And then like the other one is like open up a Swagger editor, start writing YAML or the Open API code itself, and that is as painful as. So this is where I guess something like Stoplight comes in, because it actually gives us, again, I think this is far better than using Postman for that. Obviously in Postman you can craft your request and save it to a collection, but more practically speaking, in here you can actually create your own like Swagger specification, and then and you can looks like I can only create one project. Oh, there you go, free trial. That's cool. I've got one created here. So pet store, the common example. So rather than having to create your like own spec by hand or manually, having to learn all the syntaxes and stuff like that, no thank you. You can actually use this WYSIWYG tool. So as an example, you might say let's actually add a add a model, like I want to create a model. So you can say new model, let's say account. And account, yep, that might have an ID, and every account needs an ID. And then you need a name, that's a string. You might need a type, that might actually be a not a string, that might actually be a bit of an enum, an enum having various options. So likewise, you can actually create your API spec components straight out of the UI, and it actually then generates the code behind the scenes. So you still get your open API spec, but you actually do that on the screen. So this has actually allowed my teams to develop API specs in like minutes and hours, versus like days and weeks. And then we get the C# code out of it as well, and then like we can spin up something like working. It may not be perfect, but it's still going to give you like a really quick bootstrap way of getting something running. And then similar, with your path. So you can say, I want a new path. So it's the pet stop. So let's just say, I don't think there's a delete pet. So just say pet pet ID, and then that already exists, and I'll just get an existing one. So you can create your operation, and then you can change, I guess, what that operation is, whether it's a post or or something, and then you can actually, there you go. So you can actually create, what type of request you want to do. Let's just do a delete, and then you can create an operation ID, a description, talk about security, and then talk about parameters, header parameters, query parameters, the actual request, and then you can in here, you could actually define your body, or you could actually say, what, I want to actually pick from one of my schemas, and your schema library is there, and then you can simply plug and play your schemas into your operations, and then you eventually get your Swagger, and then you can also preview what the Swagger output looks like as well. So there's really cool stuff. I probably don't have the time to go through all the features, but I guess you could probably see where I'm heading with this. And some of the other stuff that you can do, like practical stuff, within your models, you can actually create your examples as well. So you can create examples, which I kind of forgot how to do. Oh, here you go. So you can actually create an example of a JSON, response or request, and then Stoplight can actually do mock APIs built in. So you can do mock APIs in Postman or Mockun and all this other mock API tooling as well. But you are just in one platform, which is why I like it. So yeah, so you get the same concepts of Postman. You got your library of operations. Your so now that's published, and it's got branching and stuff like that. So you can hook it up to a Git repo and make sure that no one messes your spec. And then once you now found an operation, you can go and pick a mock API, send a request or pet ID. Yep, provide a pet ID. And then send the API request, and you get a response back as well. And it's the same mocking principles, but all in one integrated platform. The next one, the API catalog. So there's many examples, and the example just to showcase the principles is Atlassian Compass. It's a new product. It is now generally available. It was in beta last year, and early this year they released it, GA. Pricing is kind of good, but there are other platforms as well. There's something called Port, as well as some open source ones. Spotify made something called Backstage, which you can deploy in your own environment if you want to. And there's many examples which I can share. But the main concepts that I want to focus on are having a component registry, and then I've configured a bunch of things in here. So I've set up some of my APIs, databases, apps, etc. And then I could actually go inside the actual library and say, yep, let's look at the front end. Every component has a type. They've got a life cycle stage. Something's been developed, deployed, legacy as in deprecated. What kind of tier they belong to. Lower the tier, higher the criticality, and something like a tier 1 component. You probably don't want that to go down. Whereas a tier 4 component, like an API, a helper API, I don't know, a utility API, it could be down for a bit. So you can actually categorize on everything, descriptions. You can label them. You can put tags and labels. You can actually nominate a team for this. You can say this is owned by the front end team. You can configure your chat channels Slack, Teams, whatever. If you're using things like on-call management or on-call rostering alerting platforms like OpsGenie, PagerDuty, etc., then you can plug them in as well. Repositories, plug in your Git repo in here, and then configure your Confluence or documentation. So I've configured a Confluence in here, and that takes me projects for for your workload. So that takes me to my Jira board straight away. And then documentation, takes me to my Confluence. So I don't have to, hunt around for it. And if you have any observability dashboards, again, depending on what you use, Grafana, Splunk, Datadog, yeah, anything, the Elk stack, you could actually plug in those dashboards and links in there. So, in one hit, I now know, or I can now know everything about my web front end, and I've got all the links, and I know where to go, rather than having to, bug others and ask around or, wait, which obviously then, affects my productivity. Some of the scorecards, this is yeah, no worries, man. So some of the scorecards are quite good in the sense, and these can be configured. And the scorecard concept is about showing, I guess, engaging, how well you're actually keeping up with your components, whether it's information or whether it's about uptime or your other metrics. So as an example, component readiness, it's got 3 metrics. One is you got to plug in your repository link, meaning you need to have your repository kind of sorted. You need to have a proper description. You need to have someone owning this component. So you can actually see it's given it a 40%. It's still in the red because I haven't actually completed the other stuff. Production readiness. Do we have an on-call roster? Do we have a dashboard configured? Do we have a chat channel configured to make sure that if something pops up, we know where to go. And then this tool can then keep track of how everyone's actually maintaining your catalog, because no point in having a catalog if you're not maintaining it. And within this health section as well, you can at a glance see how well things are going. So when you take production readiness, you can see overall how you're doing, or at a component level how each of them are doing. Yeah, some of these things are 0%, and this one's 33%, still failing. You can create Jira issues out of it, etc. And then yeah, just to make sure that you got a tight operation. So some of the other key things out of a catalog you could get is the ability to actually figure out how your ecosystem hangs together. Who loves diagrams? Drawing diagrams, finding diagrams, updating them, not doing them. When it comes to architecture, I guess there are people in our teams who loves a diagram, a good diagram, but then it's a big overhead, I guess. And sometimes you just get given a JPEG. How can you now go back and edit that? We don't have the Visio file, we don't have the Draw.io file, etc. It's too painful. So this is where some of these platforms can actually let you map your architecture on the go in a more practical sense. So once you've got your component catalog up and running, you can actually start relating them to one another and connect them to one another. So I've got my front end, that's now talking to the accounts API, and if I connect, click on accounts API, I've actually had it configured to talk to my use API and accounts database, and then and then you can actually kind of go up or down the stack. So not only you can kind of keep up to date with your architecture, it's just very easy to manage, and anyone who wants to know how does things hang together or what does it depend on, you can actually see that in one go. The other good one is the activity feed. You can actually feed in your deployments, your alerts, your incidents, any other activities config changes all into this one calendar, and I've actually done that for the accounts API. And if I drill into that, go down to the activity feed, I can actually see that I had a deployment. So you can get more details out of it, and I had another deployment and another build, and then I've got an incident. So you actually combining all your information into one spot, so you can quickly see we've got an issue. Who deployed, who ran a pipeline? That's the common question, right? Who did what? Who broke my code, or who broke something or made a change, which has led to some unwanted changes. So this gives you in one-stop shop a single feed, and you can also see how someone else's component might be affecting you. So there's a lot in here, but yeah, conscious of the time, I'll move on. So then we've got internal dev tools. So I've come across this tool called ReTool. There's another one called Refine, Bubble. There's a lot of low code, no code tools. I guess the message is if you can pick up a low code, no code platform, then you can actually build some internal dev tools for yourselves. Think about like the stuff that doesn't provide you with a nice user interface. Things that you have to deal with at a database level, at a config level, at an API level, like things that technically doesn't have a fancy UI. You can easily actually make up a fancy UI and then plug it into your API, plug it into your database, etc. I mean, this is not I guess a developer example. I couldn't find one, but it's the low code, no code, concept is quite easy to pick up and make something for yourself. The gentleman who said that he's building stuff, may I ask what do you build for yourself? How do you build them? Oh yes, that's true. Yes. Anyone?
Migration tool for different databases.
Yeah. Yeah. Anything else? Yeah. Okay. Cool. Well, maybe we can do a separate session just on this. Yeah. So lots of options out there, and yeah, quite easy to pick up. And I also wanted to show a generative AI, I guess, example. So I've used Azure OpenAI, configured with a local or a private OpenAI, GPT-4 model, and then I've actually fed my private documentation into it. Again, different companies got different policies. I come from a background, I guess natively because of the organizations that I've worked for, who is more privacy security focused. So therefore, I've used this as a way of doing something privately. And it's an API, behind the scenes, the OpenAI API behind the scenes with a GUI, which you can also build yourself. But the important part is I've actually fed my swaggers into this and documentation into this, so I can actually ask more contextual questions. And I've also configured the meta prompt or the system prompt, if you're familiar with those concepts, to make sure that the bot only answers in the way that I want it to answer. And I've actually configured the way that I want it to think, probably like me or like a dev, which is not easy with all GenAI tools. So I could ask how can I create a new pet? So in the olden days, you'll find you can still find your API, your Swagger, go in there, but I don't know, I might be lazy, or I might be smart. I could ask the bot, and then the bot has given me the information. It's given me the attributes, the data model, like a sample JSON request, as well as it's showing me the reference to my documentation as well. So I could click on that, and then it'll actually show me which doesn't look too nice, but because it's the OpenAI Open API spec. And then I can also say things like create a C# model for this, and then hopefully it should reply back with a C# class that corresponds to that pet object. So very, very contextual. Make sure you pick a technology or a tool that's got memory and context, being context aware, because the last thing you need is keep telling the same thing. No, I did not mention the post. I mentioned the get or this object and that object. So this can now give me some C# classes and stuff like that. Visual Studio, you can paste a JSON, get a C# class. Copilot, you can do some of that stuff, but this can probably take that to the next level. Measuring. So how do we measure developer experience? So it's great that we've got all the tools and strategies implemented. So how do we actually know that things are actually getting better or getting worse, or even to figure out how are we doing now? So there's a bunch of concepts and frameworks. So one of the popular one is called DORA metrics. It's an independent research organization, I think run by Google or initially originated from Google. It's about having operational performance, delivery performance, and I'll cover that in a sec. And then from a well-being perspective, so this is where so DORA is kind of connected to your DevOps practices and how good you are with your DevOps strategies. But then you got the space framework, again, research by Atlassian, Microsoft, et cetera, and this is more about like developer satisfaction, like well-being, communication, efficiency, etc. Surveys, who loves a survey monkey or a Microsoft form? You can always do like low-tech stuff. Survey your devs, like run a survey, every now and then, every 6 months, just to get. Some organizations do like HR or employee engagement surveys as well, but like they don't ask the questions that like we want to be asked, or we want to provide the answers for. So you could do like a very dedicated developer survey, in addition to your HR kind of surveys. And building a culture behind the scenes as well. As we've covered, like having a sense of ownership, like building the morale of the team, just doing practical stuff. Catch up for a coffee, catch up for a beer, go for lunch. Every little thing matters in this day and age. DORA metrics. It's got 4 key components. Again, I won't go too much detail. So the first one is about deployment frequency. How often do you deploy? Once a day, once a week, once a month, once in 3 months, never. And then lead time for changes. How long does it take for you to get a ticket assigned and then push out your code or commit your code or merge your pull request, whatever you end up doing. How long does it take for you to pick up a piece of work and then finish it? And then time to restore, so it's more from an operational perspective. How long does it take for you to actually restore a failed service or an incident or react to an incident? And then change failure rate is about how many failures do you get straight after a deployment? Deploy something, get 2 bugs straight away, and then that tells the picture. And the metrics and the research has given us some, I guess levels. Like elite, high, medium, low, and you can read the whole thing if you search for Google State of DevOps report. And last demo is I guess a practical tool that can actually do both DORA metrics and space metrics called AnalysticsVerse. So this AnalysticsVerse, it's got like tons of analytics and metrics that it can capture. It actually piggybacks on 2 main sources of data, Git repos and your workload management tools such as Jira, DevOps, etc. GitHub, GitLab, doesn't matter where your repo is. So it's about actually looking at your code, your repos, activity within the repos, merge request, code commits, pull requests, branches and all of that stuff, and in a more practical sense, actual code, lines of code, like number of lines of code. And then also your work, ticket numbers, sprint numbers, etc. And then it can actually mash up all of that stuff together to actually find these DORA metrics. So deployment frequency, it can give you insights as to how they're doing. You can get a view of your repos as well, which repos had the most number of deployments, change lead time, and you can actually drill down into this as well. So this, as an example, will actually track. I got assigned a Jira ticket. I don't know, ABC-123 is the ticket number, and as long as I actually go and put that ticket number in my Git commit, then it can actually track the moment you actually pick up the ticket versus when did you actually make that commit, and it can kind of track that life cycle. Time to recover, change failure rate, etc. So there's a lot of stuff in here, and then the space metrics. So space metrics. So this can track things like satisfaction and well-being. So again, how do we know this stuff? Working over time. Again, these things can be captured, using comments that you make in your Jira tickets. Maybe you make a Jira comment or do something within Jira, after hours. You do your commits after hours or within out of regular working hours, and then you can actually track all of that stuff. How many pull request corrections you get or declines you get, rejections, and then how long, how often do you communicate? Again, using things like Jira and comments and activity. How engaging are you, and also looking at some trends and stuff like that. So there's a lot in here again, but this can actually really tell you. So if I actually click on communication as an example, it would actually tell me the team members that I that I interact with the most versus the least, and then might actually tell you that I don't know, maybe I'm only talking to one guy in the team or girl in the team, and I'm not collaborating with the others, kind of thing. So it paints a picture, and it really helps your team leads and agile leads to actually keep on top of this stuff, just to see how you're going. So I guess with that, I'll wrap up the demo, and then do a good old Q&A if anyone's got any questions. Or online. Do we take questions online, David?
We would, but
yeah.
No.
Okay. Yeah, we got one in the room.
Yeah, I've got a question on the whole space monitoring thing. Do you think that could actually run counter to the objectives if you're monitoring things like productivity? Could that actually have a negative impact on things like well-being if everyone thinks they're being a big brother over their shoulder at all times?
Yeah. You gotta take it with a pinch of salt, I guess. Doing too much will be definitely counterproductive. And it is not a everyday tool. It might be just once a month, like you check it out. And again, the frameworks have been created for a reason, and there's research to back it up. And even DORA metrics, I don't know, maybe you are part of a team who cannot deploy just yet. So maybe you got another team who is actually already up and running, doing a deployment every week, every sprint. But then you might still be building a big project that might still take you a couple of months. So you won't be deploying. So your deployment frequency is going to be zero until you are ready to ship out. So I think it is contextual and situational, I guess. But yes, too much is too much. So you have to dial it up or down based on what you are dealing with. Yeah. Yeah.
Regarding the standardized tooling, you touched on platform engineering. So how do you accommodate developers who prefer to bring their own set of tools and context? Some people don't want to bring their own background setup. They want to use your tools.
Yeah. So a couple of things. One is obviously say, here's our standard. You can't bring your own tools. Find out what they're actually using, what tools for what purpose, and then standardize it. If you don't have that, then you can standardize it within the orchestration. And again, without going into the actual tool names, but let's say you got pipelines. So someone might say, I want to have my Git repo in GitHub and use GitHub Actions. But then another team might say, I've got my code in Azure DevOps. I want to use Azure DevOps pipelines. But it's going to be a maintenance nightmare to deal with both DevOps pipelines and GitHub Actions. So you could say, understand what they're doing, and then just use one platform as your standard option. The good thing is that the tooling and the orchestration mechanisms can deal with all of them. I think it's about having a chat with the teams and figure out how much you can standardize. But again, different teams, different stacks. You might have a front end team who is on a front end stack. I'm a bit rusty on front end tools, but let's say you're a Angular React kind of team, building a front end. You got your own set of build tools and linting tools and stuff like that, versus versus an API or a backend creation team with .NET or Sprint or whatever, and then they've got their own stuff. So you could still standardize by saying, if you are creating an API, here's your stack, here's your standard tools. If you are creating a front end or updating a front end, then here's your stack. So you could still run different stacks and different tools, but maybe optimize based on the purpose.
Is that your question? Black code as well.
I'm just going to say, yeah. Oh, you got another question?
I do.
Yeah. Sure.
Big one on generative AI that you were going to be talking to. Have you run into, so I've been looking a bit at this, trying to see if we can adopt it in our team as well, but have you run into the issues of who owns the code that it writes? And that if you're using it to generate your APIs for a proprietary system, can you still own that? And have you run into those questions?
The basic principle that we apply is it's still your code, as in it's still, whoever, whichever team, generates it. They eventually owns that code. Whether it's generative AI generated, or you write it, Like it's your tool, it's your team who is actually producing that piece of code. Because eventually, like I don't think anything is actually perfect enough to go plug and play. So you still need someone to go over it, like sanity check, like make sure everything's all good. I mean, if you are blindly copying and pasting, we probably need to have a chat. But then, the idea is that like I own something. I own this workload. I generate the some code from AI. I still own that code and what I'm producing. So that's kind of like our basic principle. So what did you mention about the proprietary system, as in you are building a product? Or?
Well, if you're trying to build a product that you want to own, there's the whole legal complication of stuff generated by AI, who owns it.
Yeah.
But
it is a bit of a blur. Yeah, it is a bit of a, I guess, controversial topic. Probably wouldn't want to get into that because I don't want to give away tell the wrong thing, because it could be situational or contextual as well. I guess if you were to do something like really private and really, I mean, there are concepts like grounding, and there are concepts in generative AI where you can really control what it produces, because then you technically don't have the risk of the AI stealing code or getting code from like a public repo, because that's really where you run into those issues, because then someone may have written that code, dump it into a public repo, AI picked it up, and now you're using it. So obviously in a clear breach. Whereas if you write your own code, so GitHub Enterprise as an example can give you all of the generative AI code, but out of your own private repos, as an example. So I think in that case, you might actually be in a safer position. Yeah.
If no one else has questions, I'll take it.
Any other questions?
Yeah.
I think so. Like in my company, we use ReSharper for
Yeah.
.NET and things. Do you think like ReSharper we use for code review like improve our developer experience as per your opinion?
Yeah, I used to love ReSharper. I just don't code as much to want ReSharper. But yeah, I mean ReSharper, Sonalint, and there's those localized tools. I don't know how smart ReSharper is these days, just because I don't use it.
It's really good, by the way.
Sorry.
It's going really good.
Really good. Yeah. So yeah, that might actually be an option. Other than using something like a GitHub Copilot.
Mm-hmm.
Yeah.
Yeah. Okay. Thank you.
What are some of the tools you can use or frameworks you can use to lay the foundations of an internal developer platform?
Yeah.
Is an Azure landing zone one of those methodologies or tools?
To a certain degree, I mean the landing zone doesn't necessarily give you much other than giving you the landing zones.
Yeah.
You only get the zones. Because you still got to go and deploy and manage your stuff in there. So any of the tooling can deal with a landing zone structure. But yeah, so it won't give you the landing zone itself. So you are better off. So if you're using Azure landing zone, then pick up the what do you call that, the cloud adoption framework, source code like GitHub. You got all the bicep templating that you need to stand up a landing zone. So you still need to do your ISE or cloud governance for that.
Yeah.
But then the platform orchestration runs on top, because it's not about like governing your cloud infrastructure. It's about governing the components of the cloud that you use for your workloads. Hopefully that answers. I can give you some actual examples later on. Yeah.
Cool.
Ryan?
So I forgot what tool was, but you were comparing one of the tools earlier a lot to Postman.
Yeah,
And I'm wondering
Stoplight,
if it does it do the automated testing side?
No, it does not.
Okay.
Yeah. So not a yeah.
Not a
So it's not a one like for like. But yeah, for the purposes of doing your specs, for the purposes of storing your API documentation, descriptions about the operations objects, then I think, like personal opinion is that Stoplight, or something similar to that trumps Postman. But yeah, you obviously got the other good stuff within Postman.
Courses.
Yeah.
Thank you.
Yeah. We use it like in combination. Yeah. Yeah. Cool.
I'm wondering about some of the softer things you mentioned earlier on, like the focus time and communication and that kind of thing. Do you know of any strategies how you can see where the pain points are among the team and that kind of thing?
As in through your communication.
Well, for any of those.
Or the reasons why you have to communicate so much kind of thing.
Not necessarily that, but any of the softer things you mentioned earlier on. Like, so you've mentioned the tools to do with more technical kind of things. But
Yeah.
Yeah, there's the less technical stuff, how to
Yeah.
find out what's causing the team trouble.
Yeah, so some of them could actually be the fact that like you're asking for information. So I mean, I use Copilot Pro, and then like one of the regular things that I can ask is like what did I and David spoke about, kind of thing, and you could actually get some metrics on like the reasons why either you are getting pinged the most or like you are pinging someone else the most. So I think you still need to maybe do some investigation as to the actual root cause of your conversations as to why the devs are getting bugged all the time. So some of the practical stuff that I had to solve myself within my teams in the past as well as now is like everyone's asking for Swagger documentation. Like that's the common question. And then once you got the Swagger, can I have a secret? Can I have a bearer token or why would I need to pass this value to this field? Like there's not a lot of information, so it just keeps going on and on. So something like Compass, one-stop shop. Like you go a step back. Stoplight, you perfect your spec, so the spec is really clear, and then that goes makes it way into your Swagger, and then you got everything else in Compass as an example. So yeah, and if you got someone asking for API specs or asking about fields and operations and stuff like that, point them to Swagger. You don't have to necessarily explain stuff. So that could be one reason why a developer might be getting bugged. Could be an operational reason, like something's going down all the time. Not many people know what that thing does or how it hangs together. Again, basic stuff like maybe people don't know about the architecture. Maybe people don't know a downstream API is actually causing an upstream API or a workload to fail. So if you've got a monitoring platform, something like Compass, it can actually tell you that straight away. Whoever is interested in knowing. So you don't need a developer or a team member all the time to go and hunt down logs and look at your errors. So it could be any reason.
Yeah, it sounds like you've got some things to empower people to work or find out for themselves.
Yeah, I think once you know why the reasons why people are not that I'm against people talking to each other, but obviously like you gotta consider like developers, engineers, testers, like we are a different breed. We are not creative designers. We are not marketers. We are not financial accountants. Like developers, like we work in a different mindset, and we like certain things in a specific way. So I guess once you know those reasons, I think it's just easy to apply some of the tool-based strategies to minimize.
No, thank you.
Yeah, no worries. Yeah.
Just a quick one on the back of something like Compass. I think Compass would be like a really great tool to answer like the previous question as far as finding where some of these like inefficiencies or problems lie. But my question is like with something like Compass, coming from like a platform or a set of platforms where not everything is set up with CI/CD or automation pipelines, that sort of thing.
Mm-hmm.
How much of Compass, from your experience, is still useful once given you're working with some platforms that may not be set up with automations or CI/CD pipelines?
Yeah, glad you asked. So again, I'm not trying to sell Compass here, but I mean Compass by default can hook up to your Git repos and stuff like that, and then pull out your build pipeline activities by default. Once you hook it up. But then also again, to your example, like you don't have any pipelines and maybe you are doing things in a different way or manually or whatever. You can actually use the API to feed the data into Compass as well. So that's how I actually generated for this demo a bunch of like activities to pop up because I tried to get like GitHub configured, but it just got like too time consuming, like 12 o'clock last night, like probably not the best time to set up a demo, but it was just like really easy for me to look at Compass REST API, plug it in, and then so to your point, if you don't have an automatic system that a platform like Compass can recognize the events from, then you can still feed the data that you need. And the catalog itself is actually can be Git controlled, so you don't need people like having to manually deal with the portal. You can still do that, but you can actually back it with a Git repo as well, so you can streamline a bit. So yeah, I mean all these tools, not just Compass, got a lot of flexibility and features to kind of work around some of your practical challenges.
Cool.
Yeah,
Thank you.
no worries. Cool. All right. I think we are almost at the end. Yeah. always goes to the front. Yeah, big thank you for everyone who's come in and online.